It's my privilege to introduce Hal Lee now to talk to us. Hal is both at USC as part of the ICT unit, which is a multidisciplinary area. He actually comes from a computer science background. In addition to that university tag, he has a startup company that's incredibly influential called Pinscreen, which you see the logo on the left side there. Hal's work is internationally recognized as being some of the most advanced work in the area of dealing with digital humans. In particular, his team has been pioneering a new way about going about this that's incredibly revolutionary and quite an advance in a really astonishingly short amount of time. Hal has worked at various visual effects companies before doing the work he's doing right now. They include ILM and Weta, I just discovered. His work also fed in from his doctoral thesis, I believe, to some original face tech that has actually ended up, through a roundabout way, being the thing that allows you to do animated emojis on your iPhone. So just a very influential career already. I was lucky enough to visit his lab recently, so if the videos are playing, you might unfortunately see me at some point in this, but just to be clear, this is all Hal's work. Any manipulation, anything that I say on video, I can't be held responsible for. With that, I'm going to hand over to Hal. Thanks, Hal.
Thank you so much. Thanks, Mike, for the introduction. Thanks, Kai, for hosting this event. Yeah, so one thing that is really interesting about the work that I do is, recently I get a lot of reporters, coming to us and then, asking us, why do you guys do these things? It's terrible. Do you guys know what you're doing to the world? And we just had like a full workshop about some of these issues, and it'll become a little obvious in a bit like what I'm talking about. So we're in the business of computer graphics, right? So that's the research field that we're in, and traditionally, when you say you're a computer scientist in computer graphics, what you do is you create mathematical tools, computational models that actually try to simulate how the world looks like, right? It doesn't have to, be scientifically accurate, but it just has to look really real. And where is that mostly applied? Well, mostly in, computer animations, from Pixar, special effects in movies. Everything that we see is like fake. Everything that we see is computer generated, and the beauty of it is that anything that you can imagine, you can actually bring it onto the screen, and you can, in some ways, you can see it as you're fooling the audience, but you're also creating an illusion, and that's sort of like the fascinating thing about working in the field of computer graphics. And there was a time where we all thought, well, it seems like everything we have seen in movies, what's so special about it, right? So we're mostly taking it for granted, but there's a new aspect coming. And this new aspect is, this whole crazy idea of like, oh, what if someday, we're all gonna wear like these VR displays and then walk around, or, be at home and then try to see like be teleported into a different world. And, obviously this is not very realistic, I would say, at least in the next couple of years, that we're all gonna wear these things. But at least it's showing something really interesting in that if these computer graphics techniques or the content that we're generating in 3D is happening in real time, right? So you have 30 frames per second, 68 frames per second that you can actually generate of these interactive contents, then you can pretty much re-simulate a new environment, and then this sort of like gets into the direction of a metaverse, or creating something like the Matrix for people to live something new, right? And it can be for entertainment purposes, can be for simulation purposes. For example, if you wanted to have a better way to simulate how to fly an airplane, or these kind of tasks, it all makes sense, right? But for end users, the nightmare scenario is basically this, right? So we probably have the same problems with our cell phones already, right? So we're all day walking around like this and not, being aware of the real world anymore. And as researchers, we're thinking about like, how to solve like, little problems, incremental problems in our own field, but we also have to think a little bit outside of the field. And like, what is the whole purpose of this, right? And why are we doing all this? Is it to create better movies? Is it to create better games? Or is it to do something that has an impact on society and also an impact on what we're actually working on? And this is a major problem, which is basically how can we increase connectedness between ourselves, right? And that's sort of like what the hope is if you had cell phones, because you constantly can talk to, your family members that are abroad. You can basically talk to anyone at any time. But can you be next to someone at any time, anywhere you want, right? So, and then the key here is, can we enable social interactions in VR, right? VR beyond just wearing this thing, but a virtual simulated reality, right? And then the vision here is pretty much, the metaverse, Ready Player One. Can we, or does it even make sense to live in that world? And there are a lot of indications that show that, it's something that could change our experience of, how we would actually experience some immersive content beyond just something that is just 2D on the screen, right? And a lot of companies are working on these kind of, experiments. Here's an example from, Oculus, where they're trying to see, can we interact with each other like that? But obviously, this is not, we're not going to interact with these cartoon characters. It has to be something that could replace, something that we perceive as physically real. So the first problem here is, well, if let's say you were wearing a big box in front of your face, how the hell are you going to capture your performance? How is the system going to see what you're doing? It's occluded, right? And actually, in collaboration with Oculus, we actually worked directly with them on this problem a couple of years ago, and we developed the first head-mounted display. It looks horrible. It's nothing that you would actually sell to anyone, but it's a prototype system that shows the potential of what you could do if you had a VR headset that is also tracking your facial movements, because then it's reading what your face is doing and it could replicate your expressions inside a virtual world, right? This is sort of like the very, very first experiment we did. And it's amazing. This is like 3 years ago. 1 year later, we already moved on to something that looks slightly better, that has a slightly better form factor. This is a experiment where we only used, IR cameras that are inserted inside the VR headset, as well as a camera that is attached to monitor the mouth, right? So this is using a headset from a startup company called Fove. And what we tried to do was just, replicating the facial motions of the subject using a virtual character, right? So this is sort of like a mapping that we did. That was first experiment using deep neural networks to actually extract videos and to basically animate the character in real time, right? Without having an artist doing all the work. I specifically mentioned deep learning. It's not a misuse of the word. We're not using a tracking here. We're actually learning, this is the facial pose of a character, and this is some video of a person that we actually mapping directly. So let me show you.
Pretty soon we'll all be living in a science fiction movie, but hopefully not one of the scary ones. What do you mean that you can't make it? That wasn't part of the plan.
Right? And then if you look at life, this is sort of like how it looks like, right? So you have the person, everything is like duct tape, as part of a research experiment, and it can control this sort of like CG character.
Wow, Mars is so much more red than I imagined.
Now, and only 2 years later, after we had our collaboration with Oculus, this is something that they presented this year's SIGGRAPH, which is the major conference in the field that we work in, and it's really amazing, right? So it's really about, can we enable telepresence? Can we have a video chat beyond shitty Skype, right? The thing that never works, and every version just gets worse and worse. It's like unbelievable. Google Hangouts, right? I don't even know who's connecting. But here the idea is really like, can we see the other person, right? Can we feel the other person? And I swear to you, like if you see a three-dimensional head in front of you and they're getting close, you feel something different, right? And it's one of the most important things in addition to just communicating something, right? It's all this interaction, this ability to build trust, solve problems, and negotiate deals, have an emotional attachment to each other. So this is sort of like, the vision that they have. And obviously this is not something that is already available to end users, but it's a prototype that shows the possibilities of that. There's a reason why this type of technology is not available yet, because in order to create this experience, for each person, you need to have, a large number of videos captured from multiple views, first of all, and you need some extensive recordings for different expressions so that you can actually build a computational model so that while you use this telepresence system, the other person can't see the other person interpolated from the right angles so that you can animate the person, right, and see the other person in 3D. So unfortunately, you need a highly sophisticated capture system to generate the data. So the only thing that's available to people right now, it's a bit like the what's that called? The Memojis from Apple X, right? You select a couple of stylized avatars, or you can have the solution from Oculus. It's sort of like a little database where you can choose like how you would like to, look like, but it's all like a game character. And what I want to talk about in this presentation is how the research that we're doing is actually going toward all these photorealistic human digitizations so that anyone can access them, right? And we have a lot of things that are very promising there, and also the danger in terms of when these kind of technologies are accessible. So first of all, digital humans, how do we create them? So there is the old school way, which is sort of like the VFX production pipeline. There are a couple of big companies like Industrial Light and Magic, Weta Digital, MPC, all these companies. And what they do is they basically have a pipeline that allows you to generate virtual content using a massive amount of high-end software, but also digital artists that are creating all this digital content. So this is an interesting work that I had a chance to work on. It's called Furious 7. The actor here is fully computer generated. And the problem is basically that unfortunately Paul Walker died in a car accident. And what they needed to do is actually recreate a digital model of his head, but also make it move, right? So they need to capture someone's facial performance and reenact digital Paul Walker's face on the screen, right? There are two main issues, right? Rendering every frame or generating every image, right? Every second you have, for cinema, 24 images. And generating every single image would take hours to render. But in addition to this, it would take months to even build an asset that is sophisticated enough to fool the audience that it looks photoreal. So if you use a little bit of computer vision, and if you use all the advancement in real-time computer graphics, which is sophisticated shaders, GPUs that could actually process things in real time, you have the ability to drive a computer-generated human in real time, right? So you have a person that's wearing a mocap suit, has a camera that's capturing its facial performances. You can drive this in real time, but obviously you can see that there's something slightly uncanny about the face, right? So the face still has this artificial look, but we can get pretty close to it, right? Every year it gets better and better. And the main issue here is that still creating this asset is super, super difficult. So this is an interesting slide that actually shows different ways that we can actually create CG content of virtual humans, right? So the traditional way is you would use a visual effects pipeline, right? You hire a big VFX company, it would cost millions just to generate a couple of seconds, but then you can achieve photorealism if you pour in enough money and give enough time to the artist to achieve the goals. Now, you're using a game pipeline, your constraint is it has to be real time, at least 30 FPS. Any normal PlayStation game, probably you're hitting to 45 to 60 FPS. But then you have to give up certain things. You have to do approximations in order to achieve real-time performance. But most importantly, creating the assets is not real-time, right? It takes forever. It's very costly. And that's the reason why normal people can't generate 3D content that easily. Video content, anyone can generate. Everyone has a high-end film studio in their pocket, right? But a 3D content creation pipeline is not that easy. And it's something that, as researchers, we have to think about. How can we do something so that anyone can actually create immersive content should that be, the platform for consumption in the future? So the pitch here is that there is something new that actually came in 2012, and it has dramatically changed almost any aspect in science, right? So in computer science and engineering, right? So it has changed, health. It has changed, mechanical engineering. It has changed a lot of different fields, and that's the field of artificial intelligence, right? So a subfield of artificial intelligence is called machine learning, and more specifically, I'm pretty sure some of you have heard about this. There is almost, a new form of computation called deep learning that allows people to solve problems that were extremely difficult in the past and are suddenly possible, right? And most of these tasks are computer vision problems, right? In the field of computer vision, it's a subfield of computer science. The task of it, one of the main tasks is about how do I analyze an input picture? So let me give an example. I take a picture, and what the algorithm does is it tells me, well, there's a little dog inside, right? It can analyze, it can perform object detection. Back then, this task was extremely difficult because people had to describe what a model would be that could go from an input image to, this object that is a dog. But now we have massive amounts of training data. We have GPUs that can actually train deep neural networks and make them work. So now it is possible to do this. And in the context of computer graphics, we can do something very, very crazy. We can actually turn this deep neural network, upside down and basically say, well, given the input, a dog, generate a dog image for me. And so this is, a very, very high level way of describing what we're trying to do here. We're trying to create a new type of computation approach that is entirely based on data. And what it does is that it can generate the content that we want based on high-level descriptions. So the reason why this is possible in real time is because most of the deep neural networks are, performing on GPUs. Training takes long, but online is very fast. And you can basically generate content that is by default photoreal because your training came from real data. So let me show you a couple of examples. When people want to create digital actors, right, or they want to create virtual humans, they have to find a way to capture the first person, the physical person. So the traditional approach is to actually use a highly sophisticated capture device. So this is an example of our Lightstage 10 device, capture device. It was developed by Dr. Paul DeVevec, who's working now at Google now and was the previous head of the USC Institute for Creative Technologies. And what he developed was basically a high-end capture device it has basically multiple views that allows you to reconstruct a 3D face model, but with controlled lighting condition, you can actually not only capture high fidelity, high resolution geometries, such as pore details or small wrinkles, but also reflectance properties of the face. So what it allows you to do is actually resimulate your likeness inside a virtual environment so that it looks absolutely real. The question is now, how can we make such technology accessible to anyone, right? Well, actually, 20 years ago, a German and a Swiss gentlemen, basically what they did was they developed something called morphable face models. It's actually a technique that says that the human face can be basically compressed as a linear model. So what it means is that my face is, we have maybe, 100 people in this room. My face is basically a linear blend between all of you, right? So if I take the face of all of you, and let's say if I had the right correspondences between points on the surface, I just do a simple linear combination between them. And what happens is that if no one has ever seen me, but takes all of you, builds a statistical linear model of everyone's face in this room, you can actually reproduce my face, right? The problem is that, yes, it can reproduce something that kind of looks like my face, but you can't get to all the resolution that you want. And there's always something that is slightly uncanny about it. Something where when you look at it, you're like, this looks CG to me. This does not look real. And that's the question of how do we achieve this level of photorealism? If you go the VFX pipeline, you basically have 100 or 200 artists and a lot of supervisors that are looking at, wow, I think you need to adjust this, tweak that. And at some point, you can actually get to the result, but you don't have a formal way of describing what is photorealism, because photorealism is something that's perceptual and very, very difficult to define. So one thing has happened in the field of artificial intelligence, and in one specific field is on deep generative models. A very specific work called generative adversarial networks has been pioneered by Ian Goodfellow. And what he has created is a framework that allows you to generate content using a deep neural network that is trained with a domain-specific object, for example, faces. And given an input, a random input number, or a vector of input numbers, it can basically generate, for example, a face that never existed based on observation that it has made in the past. NVIDIA has further pushed this technique and has shown that it's capable of even generating super high resolution faces of people that don't exist. So basically, you have to think about it. It's a deep neural network where you train it, you feed it with massive amounts of real pictures. And what the deep neural network does is that afterwards, it can basically just generate a picture of a person that it thinks, this could be a potential person, but this person may never exist, right? So it's pretty impressive, but then the problem is, can it generate everyone that I want, right? Let's suppose I want to have a specific person that has this thickness of an eyebrow, this specific haircut, this shape of the nose. Then it becomes a little bit difficult because that's one of the issues of early deep neural networks. I mean, all these things are state of the art. It's one thing you can do, for example, is you can sample between different people and morph between them. So one thing that is interesting is that all the in-betweens between samples of people is what the deep neural network perceive as this is a plausible, image that could exist. But obviously, for us, when we look at that, we can see that, there are some obvious artifacts, and that's definitely something that is generated using AI. So that's one of the issues where we still have to work on, which is how can we generate interpolation techniques? How can we have low-level control of data so that it would always generate something that is plausible? And also, how can we control things? For example, I can't have a specific person with lighting coming from a specific direction. What if I wanted that part of my hair strands are white, for example? So one thing that we developed, because we work in the field of computer graphics and we really want to have control, is we try to think about a different technique. And this technique was inspired from a seminal work that is also relatively new from a person called Leon Gattis. He's actually working at Apple right now. And the technique here is about style transfer. I'm pretty sure some of you have seen some of that work. So the idea is that you take a picture of an urban city or a landscape, and you say, boom, I wanted to see how that would look like in the style of a painting of Van Gogh, right? And it would generate that for you. And one thing that we were wondering is can we just use this concept to describe photorealism? Can I actually just transfer instead of using this painting, can I use a real photograph, a high resolution photograph of someone because it's by default real, and just use that to transfer this onto a synthetic one? And that's one thing that we did, and it seemed to work. The only difficulty here was whatever you transfer to that picture would also transfer the likeness of the person, which is no longer what you want. So the research work that we did here was we tried to give us the problem of saying, hey, let's create a high-resolution 3D scan model of Muhammad Ali. There's no way we can actually invite him now to have a high-end scan. The only thing we can do is have some archive pictures and say, let's see if we can, from these archive pictures, regenerate a high-resolution photo of Muhammad Ali. So what we did was we used a database that has a lot of high-resolution pictures of people, and then developed a technique that would actually use a deep neural network that would, first of all, pick all the relevant subjects inside that database, recombine it in a very specific way so that it has all the features describing photorealism from these different people, and then recombine that and resynthesize an output that allows us to, first of all, create a photorealistic 3D model of Muhammad Ali, and also preserve its likeness based on the input photograph that I have. Let me show you a couple of examples. So on the left, you can see low-resolution pictures of the subject, and on the right, this is what the deep neural network has generated. So it's interesting because the input image on the left is very low resolution, so we even further reduce the resolution of the person. And what the deep neural network does is that it imagines how pores would look like. Right? So it creates this effect of photorealism. And then the question is, can we even generate pores like that, right? So since I have all these textures, what I want to do is actually re-illuminate these kind of objects inside a virtual environment. So we further push this technology so that it can even hallucinate pores onto a face, right? So you can see on the left, this is without the pore details. On the right, it can even, synthesize pores and wrinkles, etc. And we even pushed this further recently. You can see how fast all these advancements are. Here in this example, what we did is we have a person just taking a selfie picture using an iPhone, using a simple iPhone. And what we generated is a three-dimensional model that has the capability of generating a texture of its face as if it wasn't captured in an uncontrolled environment. It's trying to simulate how his texture would be if it was diffusely lit, and it can even capture the specularities of its face, right? So you can see that the specularities of its face are also captured. And what you can do with this is that you can actually put the person inside a highly complex illumination environment. So you can see the illumination is a little sphere up there. It's a bit like a 360 camera that you would take. And then you can re-simulate the lighting onto his face, right? And we capture really high resolution details. You can see all the pores that are being captured. So these are all, static face models. The question is, in the end, is how do we build dynamic faces, and how can we drive them, right? This is when you want to manipulate someone's face. You need to have some way to animate it. You can do it all manually. It's a lot of work, but typically what you would do in a, production setting is that you would use motion capture technologies to actually track the subject, right? So you would wear, a motion capture suit, you would track a person's face. And this is a traditional pipeline and still used pipeline at companies like Industrial Light and Magic, because there you really want to capture all the subtleties of the face, etc. So it's even like a semi-automatic approach. But since the beginning of my PhD, I've been thinking about how can we bring these type of technologies to the masses? How can we build a consumer accessible technology that would allow people to actually animate humans' faces? So how long is that ago? This is 10 years ago. When I used to have a similar haircut. During my PhD, one of my colleagues developed a super cool, real-time structural light scanner that was way before the Kinect came out. And we, developed one of the first systems that would actually, create real-time plausible facial animations using, a device that does not require you to wear, or have markers on the face. Later on, we developed a system at Industrial Light and Magic that is, real-time, could automatically track your face, and it's very similar to the idea of what you have in the, Animoji effect in the iPhone 10 right now. Let me play that video. Right, so you have one of my colleagues who's actually on the left of the picture. That's the raw input image. This is still using a depth sensor. And in the middle of it, you have his tracked face, and it can be retargeted onto an arbitrary character in real time. The problem, though, is that the character, usually the type of character that you drive are still very cartoonish. And if you wanted to drive a real person, you will still end up in the uncanny valley if you don't add, significant manual work and have more complex shading models to describe how skin reflects with the lighting. Nevertheless, we've pushed this technology further. We've used, this is an approach that does not even use a depth sensor, you just need a camera. And you can basically process any of these data in real time. So what I'm going to show you next is something that we just presented this summer at SIGGRAPH, which is basically a system that allows you to generate photoreal content using, it has an underlying tracking mechanism that uses this type of facial tracking, but what it actually does is not only puppeteer a three-dimensional model, but it can even synthesize photorealistic content. So this is how it works. So you have your app. So this is what we did at Pinscreen, right? So you have your app, you upload a picture. This is a reporter from BuzzFeed. And you upload it to the system, and the server returns to you a three-dimensional model. And it has basically a photorealistic representation of the face. So let me show you how this works. So this is actually running on the phone. I have it here. And it's driving the face. You can insert that inside a complex virtual environment. So you can see that all the rendering happens in real time. So you can actually have even more sophisticated games simply by using this type of virtual avatar that's built automatically without the need of any a team of artists, right? So this is how it works. The idea here is that on the left you have an input image of a target character that you want to drive. In the middle, you have a video of a driver. And on the right, this is basically the target person synthesized using the deep neural network. So what I'm going to do is I'm going to play that video. And you'll see that the person in the middle is actually driving the face of the guy on the left. And what's amazing here is that it's not just driving the texture of the face, it's actually generating details that it has never seen before. It can basically create teeth textures, it creates the wrinkles, it creates folds on the lips simply by, in some ways hallucinating it based on observations of many, many other subjects that it has seen before. Let me show you this next video. This actually shows it better. So on the upper right, you have images of people that we have never seen anything else from them. On the lower right, you have basically synthesized performances of these subjects. So it can bring them to life very easily. And it's really hard to see actually that, they're like, if these are fake or not fake, right? It can even synthesize, new viewpoints instead of just new expressions. And it works with a wide range of, ethnicities, genders, ages. It can deal with things like facial hair. It's all not a problem. So where is this heading toward to? So you can see that, wow, now I can do some really creepy things with whoever I want to. And we haven't even started that. Some anonymous, probably researcher, posted some code out there called deepfakes, right? And there are multiple versions of that. And it's, in some ways, it requires more input data, so you need to train for specific characters, but it allows you to do similar things, right? And what we're developing allows you to, go really beyond, because all you need is just a picture of that person. So in collaboration with BuzzFeed and Netflix, we created an interesting experiment. So in this following video, you can see that we took a driver and a favorite puppet. So so this is interesting because it's just generated from a single picture. So we have a frame of the video. And what he's going to do is he's going to drive not only his face, but even it's generating the entire scene, right? So there are many, many failure cases. This is a super experimental thing. We did cherry pick a sequence that worked, but it was automatically generated. So you'll see how cool it is.
My fellow Americans, this is not President Trump. This is Charlie Warzel from BuzzFeed News. And the future, I can assure you, is extremely terrifying.
Right, so you can imagine it's actually generating the shape of the lips and the teeth, and it's relatively plausible. Now, the even scary part of that is that it all runs in real time. So let me show you some footage, and I think the first thing we're going to see is actually a digital version of Mike Seymour. He took a picture of himself, a selfie, right? He sent it to me, and then we have our engineer, Jehu, who is taking his face, putting it onto himself, and driving it in real time. So this is how it looks like, right? So you could literally do a live stream of yourself with someone else's face. I mean, there's some apps out there, but they don't look as photoreal as this, right? And it's actually generating, all the, per frame, every facial expressions and emotions of the person. So the lamp here is really to demonstrate how the digital face is interacting with the environment. Right, so it's not even a very good picture of Ryan Gosling, right? It's like a stylized. So let's declare. So if you guys have some interesting stories that we can do with this, let me know. Anyway, the question is, how good is it, right? And one of the cool things we did when Mike was visiting us was he came up with this idea of like, hey, let's do this experiment. I want to know how good it is. I mean, based on that one single picture, how do I even know? How does it know how I smile? And I said it doesn't, but it creates something that kind of looks plausible. And this is what we did, right? So we did a simple experiment. On the left, you have the original Mike video. On the right, it's the same video, but the face is computer generated, and it's generated from a single picture. So what we did was we just put them side by side and then just let it render and then see how the real and the fake looks like.
Okay, so here I am actually in the offices of Pinscreen, getting my face scanned, or rather actually just photographed on an iPhone, which is great, don't get me wrong. I'm just used to bigger cameras with more tech, not just one being held in someone's hand with a Mickey Mouse back on it.
Right, so this gives you an idea of like how good the prediction could be, right? Of course, there are a lot of subtleties, like certain ways that Mike would smile, or his emotions are not necessarily transferred, but it might be sufficient, to fool certain people for certain applications. Okay, I talked a lot about faces and how to bring them to life. How about hair, right? I want to create like entire heads of people, and it's like super important for virtual characters and also for. Okay, you got it. Hair is super difficult for computer graphics scientists. You have movies like Brave, and it's hard to create, it's hard to design, it's hard to simulate their emotions, because hair is something that is so complicated, right? It has a lot of frictions, contact mechanics are super complex, and even to render it is extremely hard. It's not just the surface. I mean, the skin also has a subsurface, but hair is something that is by itself volumetric and has a very complex way of being, of appearing, right? And that's one of these typical problems where it's really good to use a data-driven, if not even a deep learning approach to improve it. So we're actually one of the very few labs in the world, and hopefully there will be more soon. Some are starting to work on that as well, to actually work on hair digitalization, right? So the idea is that normally hair is created by a CG artist that would have some tools to create some splines, and then they would procedurally generate certain hair. We're trying to see if we can automate that, right? So this is some old work we did a couple of years ago. You give it an input image, you put a few strokes, and then the idea is like, can I recreate the entire hair model just based on that, unconstrained input image, right? If you add the right priors, for the specific cases, you can even generate a really complex one, like braided hair, right? So all these things are some of the milestones that my students have worked on, but all of them had a big issue, right? So they would work in experimental capture settings, but in the wild, why don't we have these tools that make them work all the time. I mean, we have a very sophisticated one that you can download from our Pinscreen app, right? So we actually have an app for these avatars. There's a very sophisticated, but still, it would fail sometimes, right? They're not completely fail-safe. And it's the same problem like all these computer vision problems. If you use a scalable technique like deep neural networks, you can actually make them extremely robust, right? So we developed this three-dimensional convolutional neural network that could actually generate three-dimensional hair using a 3D convolutional neural network that has the ability to parse random input images and then map them to a high-dimensional feature space and then redecode it into a 3D hair model. So let me show you how it looks like. So we have input images of these kind of hair models. So it has never seen them, but based on massive amounts of training data, it can actually map this into a 3D model. And it's fully automatic, right? There is no human that is guiding anything. It has this input image and it just generates it. And it even knows what the hair is, right? It doesn't perform any segmentation or anything. This is also interesting. You take that picture, it knows even exotic hairstyles, what is the most likely way of them. It doesn't even have to see a face. You provide this as an input picture, it thinks this is the hair model. It's as crazy as it is, right? It's really trying to model how humans would perceive things and based on what their priors are. Now it gets really crazy. I can provide a Picasso painting and it knows that this is probably the most likely hair that it would generate. Or I can put a Bitmoji and it knows this is the hair, right? It's sometimes it's really hard to believe, especially when you put this as input. So the face is like a mock-up, right? But the hair is actually generated. And from a scientific standpoint, that's super good because a lot of people ask me like, how many models do you use to create them? Well, you use a certain amount to train them, but in the end, you have infinite amount of hair models because you can sample them in this high-dimensional, what we call a manifold, right? And you can interpolate between hairstyles and always generate something that is plausible. Now, this is not only for modeling hair models, it's also for rendering them, right? Rendering is basically the process. Given a 3D hair model, how can we generate an image of it that looks photoreal? And that's a task that is extremely difficult, especially for hair, because we need to know where does the light come from. We need to simulate the bounces of hair, of light onto the hair, etc. So we're taking a similar approach recently. That's something that we just presented 1 or 2 weeks ago in Munich, which is a system that is trained purely based on on data that can render a hair, a CG hair that looks, decent. And this is the way it works. We have a system that has 3 high-end GPU machines. So it's like gaming graphics processing units. Usually you just need one. So we put 3 together, and each of them basically translate the rendering, a random rendering of hair into an intermediate representation until it gets to a hair model that has a photorealistic look. So his input is a CG hair model, and it generates this image of it without having, any model of what light or computation is. It just generates a hair. And one thing that you can do is you can say, well, I want to know how this hair would look like if I had, a blunt hair model, such as, so here you just load this random image, and by having this image as input, it knows that this is sort of like a plausible way of how hair could look like. And the thing that we're doing is we're not only looking at, human faces, human hair, we're also looking at the entire human body. So we're trying to, solve some of the problems that allows us to do full body performance capture for AR applications, such as, 3D live streaming. And a lot of big companies like Microsoft are working on this. There are a couple of these big studios in, Los Angeles. I mean, you have now from Fox, Sony, they're all deploying these high-end capture systems that allows you to, collect dynamic content and process the data. So this is a setup from the holoportation system from Microsoft. Consists of hundreds of cameras, both passive and active, And what you can do is in this studio, you have a subject, you can capture its animations and then recreate a 3D data. We want to look further. How can we make this accessible to everyone? Not everyone can afford this billion-dollar setting. Or we don't want to have a green screen studio. And can we do the same thing with just 3 or 4 cameras? So we're doing some experiments using deep neural networks. The idea's whole philosophy is very similar, right? It's like, what if I had massive amounts of data to train a deep neural network to understand what the human shape looks like? So in this experiment, what we did is well, it's really hard to collect a lot of people, so we just generate them using CG. And we were wondering the following: what if I just generated these like game character-looking models? They don't even look realistic, but would it be sufficient to understand how the shape of a human body looks like? And it turns out that it actually works out, right? So we took these 4 synchronized videos from a database from MIT, right? It's actually one of my friends doing handstand. And this is impossible to do multi-view stereo using just these 4 views. But the idea is like, based on these 4 views, can I reconstruct a plausible human shape of it? And it turned out to work by simply training with these CG content that you have seen before, right? So the guy you see on the second row is the shape and animation of the 4 views in 3D. So the question is, what's next, right? So I think this sort of like concludes this talk. We're looking at how do we digitize virtual humans, right? And what it shows is that if you use a lot of data that you can collect in the wild, you can actually train, machine learning systems to understand how they look like. And we show promising directions in how it can predict using very, very limited information. In terms of application, I think all this kind of work is really, important because it allows people to. I was talking about communication. The other thing is about content creation. Can people tell stories? Can people create immersive content by themselves, right? So it's really about democratizing the idea of CG content creation without the need of game studios. And what is the level of quality that we're looking at? We're really looking at VFX quality, something that is beyond what we can typically, what we typically see that we perceive as game quality. Everything has to look like as if it's actually there, right? So, and VFX is in some ways a slow version of augmented reality. Ultimately, I think one thing that's interesting is right now, if you want to look for content, you go to YouTube, you type in a search, a keyword, and you say, hey, I'm looking for a dancing puppy, right? So if someone had a recording of that or has tagged some information on that, you would be able to get that data. But then you're only limited to what people have done before. Ultimately, what we want to do in computer graphics is develop a system that actually generates the content that you actually want, right? You imagine whatever you want, and it would basically generate the content for you. Also, I think we're working on virtual humans. I think at some point we're going to interact with 3D avatars, right? So people who are going to help us, in electronic commerce, people we interact with, 3D chatbots, or people that would, or a system that would allow us to preview how we would look like in certain clothings, stuff like that. Another thing that's really interesting that I think it's a little bit complementary to our traditional thinking of how to sell products and how to perceive things is there's also a trend in general in e-commerce about how things are going into we're no longer, for example, if we're looking at clothing, we're not only looking at fashion models, right? So one big thing is about influencers on Instagram, right? So there's this new feature where you're on Instagram, you can look at these people. So it's not only real people that we're looking at. There's also some interesting developments in terms of CG people or virtual influencers that are not even real people, but they have millions of followers that we're interacting with. So I think it's going to be interesting, like how this world is like, merging between real and virtual, and yeah. So I think these are all the things that we're looking into. There's more than just fake news, right? So there's a lot of interesting avenues there, and yeah. So I'm open to questions. Thank you.
So we have time for just a couple of quick questions, and then of course you'll be hanging around for drinks, and you can obviously answer more. Do we have any questions? Does that, no? Okay. Well, I'm going to ask you a question. I found it very amusing that you said a seminal paper from like 2 years ago. Do you like, I mean, like, how do you get the word out if like if everything's moving so quickly, apart from like things like this, given that like it can take 2 years to publish an academic paper, like how are you getting out and into the community?
I think, well, I think it's the same question as like, how do you get to something that's successful? I mean, things have changed a lot recently, and it's hard to answer that question. I mean, until probably 5 years ago, when you do your research, you basically have like 1 or 2 big works, and it's like one of many. And then I think since this whole explosion of deep learning, things are just changing massively, right? So the progress that even the students are doing in my lab, like even I have a difficult time catching up with like what they're doing. And then there's a question of like, how do you make your work visible, to the world? Who are these? They're usually just, there's still very few, people that are, really on top of their games and always working on big things. But, you definitely have an explosion of papers, and it's hard to navigate like what is out there, what are the things that, what are the papers that actually matter. I do think that media channels like YouTube actually help a lot, right? So some of the works just have like millions of views suddenly, and it's obvious that they are changing something, right? They're enabling new capabilities. So I think many of them are application driven, right? So a lot of the work that I did that we're working on is, oh, that was a hard problem that wasn't possible before. And then when you have a work out there, then it's already something that people are expecting.
So Hal and I both on our phones have versions of Pinscreen software. If you want to see us during drinks, you can play with this yourself. It just falls on me to say thank you again, Hal, for coming and presenting that stuff for us. Thank you.
Yeah, thank you.
Thank you, Hal. That's for you.
Oh, thank you.
Something for the flight back.
Oh my God.
I find you incredibly humble, right? That you come here and you present this, and then we did this and we did that. I hope you realize that we're witnessing history being made, right? Because this is a big step. The implications will be huge. Not only will this allow completely new forms of interaction and visualizations and entertainment that we are yet to understand where we're going. But these technologies are being built not just in Hal's lab, but also around the world and being democratized. And this is happening, right? Whether this is done in academic settings or not, this will fundamentally alter how we engage with content on the internet and what we can believe and what will happen. So there's a real rethinking underway. It comforts me that this work is done in academic settings, that we're working on this to try and understand what the implications are. With Mike, who's leading research in our Motors Lab in Sydney, and us collaborating, at least we're in the game and we can actually have a little bit of control over where things are going, because this is happening, and corporates and also not so like nefarious actors will jump on these technologies. We've talked about election tampering and Facebook, and there's all kinds of crazy applications that we can think about in those settings, but there's also incredible opportunities in healthcare and aged care and other settings where this can really help do good. So I think I think this is really amazing, right? I like how humble you are, but also it is interesting to just see how much hard work goes into making incremental process that then to the uninitiating just looks like magic.
Yeah,
right?
but
so I think that it is good to actually get that sense sometimes.
Just to add something, I think, I mean, first of all, all these work are not possible without building on top of a lot of people's work. But one thing that is kind of interesting right now is, as researchers, we feel like it's a gold mine, right? We're at the point where there is something new that came, right? This whole AI and deep neural network, blah blah blah. From a research standpoint, we're basically given. It's a bit like something fell from the sky, and whatever you do is like, oh, this is possible suddenly. Yeah. Oh my God, what's happening, right? It wasn't like that until 5-6 years ago. 5-6 years ago, we were like working super hard on, then it was really incremental. It was, wow, we have another, milestone. But suddenly things are accelerating so fast that...
so that is essentially what we call a disruptive technology. Right?
Yeah,
so
sure.
Consider yourself disrupted. Thank you everyone for staying on.